I'll do an intro of it.
Okay,
So.
great. Hi, everyone. Thanks for attending today's workshop on biochar and its application on urban farms. My name is Yolanda Gonzalez. I'm with Cornell Cooperative Extension Harvest New York Urban Ag Team. And this is an ongoing webinar series as part of CAMP. CAMP stands for Climate Adaptation Mitigation Program. And today we'll be welcoming Debbie Heller from New York 4, and I'll just hand it over and we'll take it from there.
Great. Thanks so much, Yolanda. Really appreciate the opportunity to be with you all today virtually and tell you a little bit about New York Core and then dive into some information about biochar and application on urban farms. So I will briefly give an introduction of myself in another slide, but I'm going to take the first few minutes to introduce New York Core, which is the New York Center for Organics Recycling Education, of which I'm the director of. It's an evolution of the Cornell Waste Management Institute, if you'd heard of that institute before, which has been or had been at Cornell for almost 40 years before we essentially rebranded to New York Core. We are a statewide applied research and extension program at Cornell University, so based in Ithaca, New York, but we work statewide, including with urban farms. We have an emphasis on working with the agricultural community and farmers as a whole. We're supported by DEC, and the whole premise behind New York Core is really stop thinking about what really are resources. So stop thinking about them as waste, but as resources. So all organic material are sources of carbon and nutrients. And can we think about these as resources that we can use back on farmland? So overall, how Cornell kind of fits into this umbrella of Cornell. We have Cornell University, College of Ag and Life Sciences, these translational research programs, these statewide programs, and then New York Core falls under with many of these other programs that you may have heard of, New York Soil Health, Pro Dairy, etc. And so our focus is to provide New York State stakeholders with science-based research, education, outreach, training, and technical assistance related to organic materials management. As I mentioned, well, this is our team, myself, Debbie, the director. I'm a soil scientist by training, and I've really focused on the organic side of things for about 14 years. My expertise and all my background is actually with biochar, and so that's why I was super excited when Yolanda invited me to speak with you all today, and share a little bit of my knowledge with you. Let me grab the laser pointer, actually. With me on my team is Jean Bonital. She's been working in the organic space for 35-ish years, and she's set to retire at the end of next month. And she's been a force within the organic sector. And so really thankful for all her work and her being a part of the team during these transition months. Jesse Kearns is an extension associate. He's been working with organics for a number of years and has a really great expertise in sustainable materials management. And he came over to Cornell from Syracuse University. And then part-time on our team is Hannah Shaler. So I'm just going to outline some goals and program activities that we do at New York Core, and I'm providing this introduction because I wanted to make sure everyone is aware of us as an entity here in New York State that can provide technical assistance to farmers, municipalities, individuals, community gardens as a whole, as it comes to organics management. And this is thinking about in light of the food donations and food scraps recycling law, and thinking about how do we divert resources, these carbon and nutrient resources from our landfills back to our farmland and other more beneficial applications. And so that's why I'm providing this introduction today. And so this is just outlining some of what we do, providing that hands-on training through workshops and other events, direct technical assistance, and helping respond to emerging threats and develop best management practices around organics management. So we have a new logo. Like I mentioned, we're completely rebranded from the Cornell Waste Management Institute. We have a whole new website here where you can find a lot of information about biochar, about compost, biosolids, wood chips, many different topics. Here is a QR code directly to the website. So if you scan that, it will take you directly to our new website. If you start seeing this logo around or in collaboration with other entities, this is who we are. We are developing new resources and updating old resources as part of our work. So these are just some of the new fact sheets that we have put out recently in response to some farmer needs and needs of our cooperative extension educators as well in the work they do. So as I mentioned, some of our major focus areas are around composting, providing that technical assistance directly to farms to improve efficiency, and uh, just practices around composting. These are all different types of composting, depending upon what feedstocks farmers have. Obviously, do a lot of work with biochar, which I'm talking about today. Biosolids not something very relevant to urban farms, but just as a larger topic in New York State and the Northeast. And then other areas of focus we have around organics materials. So as I mentioned, one of the key things that we do is providing farmers with technical assistance to handle things like high residual materials and composting those properly, building compost structures to have on-farm composting, whether this be three-bin systems, bays, or other structures that are suitable for that farm, helping with siting and improving the efficiency of composting. For example, this is essentially a pile of manure and bedded pack, but there are opportunities to actually improve the composting around that on farms. We do provide other direct technical assistance to municipalities, to compost facilities, and then also on the end use of the actual material. How do you get that back to farms? How do you get that on the landscape and use it in a beneficial manner? Do a lot of stakeholder engagement and education through master composter training, master gardener trainings, student groups, and others like that. Uh, we do partner with a lot of other groups on field days and workshops. For example, partnering with Yolanda and the Urban Ag team in New York to do workshops, New York Soil Health and others. So we do these across the state, and it's a really great outreach from our program. Conduct applied research. So thinking about how do we go from dairy manure to biochar. This is one example of some applied research we have here in New York State in thinking about better management or different handling of organic materials. So that's my really quick, brief overview of New York Core, just so you have you're aware of who we are and some of the services that we can provide. If you are a farm and you're thinking about I have a CSA operation and I'd like to get some of those food scraps back so I can produce compost and use that compost back on my beds or within my fields. And so that's something we can assist with. We do have a quarterly newsletter that just mailed out 4 times a year. You can sign up for that directly by scanning that QR code on the screen. We also do have a social media presence now, so we're trying to stay a little bit more up to date and share some of the activities we're doing around the state. So feel free to follow us if you do have any of those social media platforms. And so with that, I will actually dive right into what we're all here to learn about today, which is biochar and thinking about its relationship to urban farms and how it can be used in the urban landscape. I will say a bunch of my pictures might be larger scale or relevant to larger agriculture or field production agriculture and I mostly work I do some in urban areas, but most of my work has been on larger farms. So apologies for some of those pictures, but I'm really trying to connect it back to the urban farms and often smaller farms and garden bed type systems. So With that being said, what is biochar? I really think it's always important to start at the basics and kind of the 101 so everyone's on the same page of what it is. So it's a carbon-rich material made through pyrolysis. It's the conversion of any organic waste material into this biochar product. And so biochar is essentially charcoal that is used as a soil amendment. It is not a fuel. It is amendment to improve soil for various means, largely for improved crop production, but also organic carbon improvement, and many other benefits. And so pyrolysis is a thermochemical decomposition of this biomass of the organic material at high temperatures in no to very low oxygen conditions. So pyrolysis is different than incineration and combustion. So if you think of like a campfire that's open to the atmosphere, there's oxygen there. It's combusting, it's producing ash, a lot of ash. But we're not getting that with pyrolysis. We're not really we're burning it without oxygen. And so we're really stabilizing the carbon there. And I'll talk about that a little bit more. And so pyrolysis produces three co-products. When we're talking about larger scale production, gases, which are these syngases, can go to electricity production. Liquids or these oils and tars can go to like bio-based products and bioasphalts and things like that. And then we have our solid biochar product. And this is really what we're focusing on in the agricultural space. And so here's just a picture of what a raw feedstock would look like and what it looks like after it's been subject to pyrolysis, and we have biochar. Like I mentioned, it's a charcoal-like material. It is essentially charcoal, but not used as a fuel, right? Used as a soil amendment. Most biochar is about 50 to 90% carbon, so it's incredibly carbon rich. And when we think of the climate adaptation and mitigation, it's an incredible tool for that. And so biochars that are about 50% carbon are ones produced from things like manure. Our feedstocks are manure, whereas woody-based biochars are about those 90% um, um, carbon amount in the biochar itself. So really high carbon fractions. Biochars are very highly porous. I like to use the analogy of like a sponge. So they have all different size and shape pores that are connected or separate, and these pores really hold on to the water and nutrients and act as a home for microorganisms. So really, they really soak up and release, but also retain water and nutrients in the soil system. And they're incredibly long-lasting soil amendment, of which I'm going to talk about a little bit more. So one of the beauties of biochar production is that can occur at many, many different scales, from incredibly low-tech systems to really industrial scale, where we have these integrated bioenergy biochar systems, where the process is actually optimizing the gases and liquid production, and to a lesser extent, the biochar, the solid material production. There's on-farm biochar production, um, and then mobile units. This has been really popular out west for wildfire management and or mitigation of wildfires and actually pyrolyzing woody debris on site to not have them ignite and start a wildfire. And then container reactors that are essentially shipping containers. These can move to different areas, and then you have a full-blown pyrolysis system, and then small kilns. And when we talk about urban farming, urban agriculture, and production on site, we're really talking about the small scale or artisanal biochar type production systems. And so these are three different examples of these small scale pyrolysis kilns. Is my video completely lagging? I'm realizing that. Um,
It might be, but we can see the slides okay, so.
okay. I don't know if I should turn off my video. I guess I can leave it on, but apologies
Sure.
for that. I'm in the office, so my Wi-Fi should be good. But hopefully there's no delay with my voice.
The audio is good on my end.
Okay, great. Thanks, Yolanda. So these are just an example of three different kind of small scale or artisanal biochar kilns that might be the size of kiln that could be used to produce biochar on site in an urban setting. So some of these larger scale systems or kind of open organic um, burning on farms is not going to work right in an urban setting where you have a lot of people. So we're really thinking about these small confined spaces where we might have a smaller amount of organic material to pyrolyze, or we might be able to do small batches more consistently as we have organic waste materials. And so one thing I'll say with this is that if you're interested in producing biochar on your farm, they're thinking about how much feedstock you have on a regular basis, what is the size of that material, that those kind of throughput types information it will guide what size kiln you're looking for and what might be the best fit for your production on site. So not to have a complicated process, but I just really want to, or a complicated shot slide. I kind of want to just share the process a little bit more with pyrolysis, and really what's going on. And so if we take the three major components of a woody waste material, or a wood, so cellulose, hemicellulose, and lignin, which we can see kind of components of that on the left, and we subject it to pyrolysis, we get what we call is kind of this fused aromatic carbon um, structure. And the whole point of this is that pyrolysis really makes these organic compounds more complex. So they become incredibly difficult to break down through um, physical and chemical weathering, but more importantly, through biological activity. And so they become really stable once they've gone through pyrolysis and once they're applied into the soil environment. And there's many factors happening in the pyrolysis process, but the main thing is that it's really creating these more complex structures that are incredibly stable. And so there are numerous benefits of biochar within agriculture and beyond. A few of those I've listed here. I think some that are really, really important beyond just the agricultural benefits we see from improvements in water use efficiency and water retention and nutrient use efficiency and microbial activity. Um, our soil remediation, there's a lot of interest in utilizing biochar in lieu of more expensive activated charcoal products for remediating contaminated soil. I think everyone knows there are issues with contamination, particularly in urban soils. And so there's a lot of interest in utilizing biochar for remediation. For obviously the waste management. So how do you process or transform those organic materials on site and reuse them back in a beneficial way, instead of disposing them potentially in a landfill? How are those sources of carbon and nutrients? And then really that climate mitigation and adaptation standpoint. One of the reasons you're all involved in this program is that there are plenty of adaptation and mitigation compo or benefits associated with biochar, all that carbon that we're putting back into the soil and storing for hundreds of thousands of years. So biochar is really another tool in the toolbox for farmers when we think about organic amendments and ways to improve soil health and improve agricultural sustainability. Um, but it's another tool and it's not a silver bullet, right? And utilizing biochar alongside compost and other amendments that you're already using on farm. And so we're thinking about its integration alongside existing practices that you might be doing on your farm, thinking about cover cropping, thinking about diversity of rotations, which I know is not an issue on urban farms. There's hundreds of varieties often grown. And then I'm going to talk about this idea of the four R's. And so I get asked a lot, biochar versus compost. What's the difference? And why would I be thinking about utilizing biochar over compost? I think most growers, and home gardeners, community gardeners, they're familiar with compost, but they're not as familiar with biochar. And one of the key things that sets biochar apart from compost is this stability that I've mentioned, kind of this long-term stabilization of the carbon in the soil and the slow degradation rate of biochar compared to compost. So they're both organic amendments, but compost degrades much more quickly than biochar does. So this is just kind of a graphic, an infographic, just to portray if we put uncharred organic material into the soil versus the equivalent biochar, the amount of carbon that gets stabilized and remains in that soil over the same period of time is significantly higher than that uncharred material. And so that carbon, which I think I'll mention in a few slides, but there's tremendous benefits to adding carbon, right? And to adding soil organic matter in the soil. So if we're stabilizing it over long periods of time, we're seeing those benefits over longer periods of time. And so other than actually physically planting trees, biochar is really the next best way we're adding carbon in a stable form to our soils. Don't get worried if this looks very complex. I do like showing these graphics to really just present some data to you all. And I do think they're really good figures from a couple papers that are quite a few years old now, but present a lot of great information. And so it's that idea that biochar is very stable, but it's dependent upon the feedstock, so the organic or the starting organic a waste material that you're utilizing to produce biochar, and then the production conditions, so the conditions at which you're producing it, and the type of the production. And so this figure on the left, all it's really showing is that across a diversity of feedstocks used to make biochar, whether it be a crop residue, a manure, or a woody waste material, you do get some variability in the amount of carbon and biochar remaining in the soil over time, but still overall, it's a significant amount of that material, more than 85% in all cases over several years of application. And this figure on the right, really what it's showing is the connection between pyrolysis temperature, so once again, the production temperature, and the amount of carbon remaining in the soil on the y-axis here, and then something called the hydrogen to carbon or H to C ratio, which is an indicator of biochar stability in the soil. And so what we're seeing is that the higher the pyrolysis temperature, so the temperature at which biochar is produced, the more carbon is stabilized within the biochar. And so that has a direct result for, right, it's longevity in the soil. So it's breaking down over time.
Hey Debbie,
You
if you
go,
want to just
yep.
try taking up the camera, there was a little bit of a lag there.
Okay, let me do that. All right. I'm trying to get to the display setting. Ah, sorry, I'm trying to. One second. Okay, let me get back into view. Is that a little bit better now that I turned off my video?
I think so.
Okay. Okay, so yeah, just chime in if there is a delay again or any technical issues. Um so biochar is incredibly diverse. Kind of hopefully you've gotten that point because of that original starting feedstock and production conditions. So these are just some really nice scanning electron microscope images of the same feedstock, different production conditions, and some of that variability that we get here different feedstocks, different production conditions. So just want you to get the sense that, biochars are not all equal. There's an incredible diversity around biochars, and these lead to different impacts. And these impacts are soil by crop, by biochar, environment, management dependent interactions. And then there's some other aspects that we think about, which might be a little bit too technical, but this idea that the properties of biochars can change over time, whether they're freshly produced or they're aged or weathered in the soil. And then these designer type biochars, which can be used for specific end uses. For example, if you're looking to improve the specific surface area of the biochar for remediation purposes, for for removing soil contaminants. So like I said, just letting biochar is not just biochar, it's biochars, and they're really not all the same. And I like to think that this can actually be our advantage in agriculture, whether you're a large scale farmer or a small scale farmer in an urban environment. There, there can be a reason to use different types of biochars or different biochar products to improve the soil on your farm. And so this picture on the bottom here just gives you a sense of some of the products that are out there and you might see on the market when it comes to biochar. So these raw biochars, these are the freshly produced biochar that you might produce on site through that small scale production. Pelletized and granular biochars. This is kind of where the large scale, I would say, where the industry is going in terms of creating these blended biochar and fertilizer products where you can get both the carbon and the nutrients all in one form. It eases transportation and improves the efficiency of application of the product. So those are, I would say, they're increasing in production, and it's really this whole biochar-based fertilizer idea of where the industry is going. Blended biochar products are very common. This is probably what most folks do is take that raw biochar, blend it with compost or manure or another nutrient-rich material, and you get this blended biochar product. And then there's these liquid biochars. So these are really micronized or pulverized biochars that are then suspended in water, for example, and can be put through fertigation equipment if you fertigate on your farm, or can be put through overhead irrigation. But essentially they can be injected or surface applied, but they're essentially a liquid form of biochar. Just want to make everyone aware that the biochar industry is expanding or, it's evolving very quickly. There's a lot of work going on around certifications and standards to really um, uh, increase let's say the reliability, and so people know what they are buying when they are buying biochar at the end of the day, and the potential impacts it's going to have in your system. So there's a lot happening in this space right now around certifying biochars to guarantee the quality of the material, to improve the reliability of the product. So decrease uh eliminate potential safety concerns or issues consumers might have when it comes to purchasing biochar. So just improving the or let's say not I'm fumbling my words here because I'm trying to think of what's the right way to say, but essentially to do no harm in a way for biochar of that there's differences in qualities, there's a diversity of products, but that they're reliable and safe for application. So there's a lot of work happening in this space right now to create standards around biochar use. So just wanted to make folks aware of that. And in the US, this is really being led by the American Biochar Institute, previously the United States Biochar Initiative. If you are purchasing biochar as a farmer and thinking about applying it, similar to how you can get a compost test report or a soil test report, you can also get a biochar test report. Looks very similar, gives you some idea of, how much carbon is that material, what is the ash content, pH value, liming potential of the material, what is the nutrient content over there of the material. Are there any concerns with heavy metals with that product? So this is a pretty standard lab report here. And a lot of questions I get are around biochar potentially being used to replace agricultural lime. And what is how do I know if my biochar is going to have a liming potential associated with it? And so in that case, it's important to look at the ash fraction, the pH value, and the liming and carbonates values on a test report to get some idea of what would be the calcium carbonate equivalent and the liming potential of that material. So there's just a lot of value in seeing a test report if you are purchasing biochar, and also if you're looking to make it yourself to send it off to a lab for testing. There's a great fact sheet that we put out. This was in collaboration with ABI how do you interpret a biochar lab report. So just like how do you understand a soil test report, we have this information out for biochar lab reports. You can scan the QR code and get to this fact sheet. Some availability and cost around biochar. This is another question that I often get from farmers because right the economics of it. And so a number of years ago biochar was incredibly expensive, and definitely at large scale. It was not being utilized. That's really changing. I'd say at smaller scales, home garden level, urban farm level, it's been way more accessible, particularly with higher value crop production. More growers are have been utilizing biochar in urban farms and smaller scale production. Um, and it is available widely at this point, I would say. Cost does remain higher than other amendments that many farmers use, like compost, for example. I like to say you can get biochar anywhere from being free to about $2,000 a ton. About the national average is around $500 a ton now. I'd say that's continuing to go down as uh, suppliers are looking for end markets. But it does certainly vary depending upon where you are. Here in the Northeast, biochar is a little bit more expensive than I would say out in California. But a lot of the cost around biochar, if you're looking to purchase it, is related to transportation. And so sourcing local is great where possible. And that being said, there are a number of suppliers across the Northeast. I'm working with American Farmland Trust right now on a project, and we're producing a national biochar suppliers map. And so I've just taken a snapshot of that for the Northeast of kind of where some of the larger known suppliers are. We have a few here in New York, mostly in the upstate New York region, but this continues to change very rapidly. So getting back into the ag side of things, and I'm going to show some more urban examples at the end, but this is all still relevant to the urban production. Is that biochar? So this was a study of across thousands, or it's a systematic review of thousands, hundreds and thousands of studies that have looked at biochar in different regions, different soils, different crop production, and overall, what were the agronomic impacts found across those many studies? And so, what these researchers found is that overall, there's more than a 10% increase in crop yields following biochar applications compared to a no biochar application, improvements in photosynthetic rate, water use efficiency, increases in root biomass, microbial biomass, soil organic carbon, many, many parameters related to crop production. So this is a really, really nice study, and a lot of people show this slide in presentations just because it's a great summary of the overall or potential benefits biochar could provide in a agricultural setting. This is a table I put together just summarizing, the benefits biochar can have to soil properties. And it's because biochar builds soil organic carbon. And we know soil organic carbon, or many folks think about soil organic matter, the benefits that that has to soil properties. So improvements in microbial activity and water infiltration, cation exchange capacity, nutrient cycling, and a lot of, decreases in things like leaching and compaction, and a reduction in odors and erosion. So this is just a summary table of that. So a lot of the benefits we see from a soil standpoint through biochar applications. And so, as a farmer, if you're thinking about biochar, you're looking to utilize it, a great place to start, or really where when I'm meeting with farmers, is thinking about what is the resource concern you have? Why are you looking to utilize biochar? Because it's not a one size fits all product, as hopefully I've been able to convey in my previous slides. But you, as a farmer, in thinking about just like why you apply fertilizer or why you're applying compost. Um, why would you be interested in applying biochar? So thinking about, do I have issues with water holding capacity in my soil? I'm looking to improve water retention, or I'm looking to boost microbial activity. I'm looking to increase organic matter. Um, Organic matter is typically not an issue in urban areas, but it can be. But these are just some of the factors or the soil and production factors we see of why you might be interested in applying biochar. So it's thinking about in the context of your farm, in your production system, what are the issues you have, and why might you be interested in applying biochar? Um, One approach that we've taken in terms of kind of discussing biochar within agriculture is this idea of the four R's, and utilizing the four R's when it comes to making biochar decisions. And the four R's came out of kind of the Fertilizer Institute many, many years ago, in terms of better management around nutrients and fertilizer application. So we're not over applying it, we're not getting losses, and we're not, also losing money and having the environmental consequences around that. So it was around improving efficiency and better utilization of fertilizer. And that's kind of worked really nicely in talking about biochar and thinking about what is the right source of biochar. What I mentioned, kind of that local resources. So maybe in New York City, thinking about woody materials, or whether it be wood chips or some tree trimmings, or some crop residues or leafy materials. There are organics in the city that are a great source for producing biochar. The right rate, how do I know how much to apply on my beds or within my fields? The right place, thinking about the rooting zone of a plant, in the right time. So the right time is something I'm going to talk about, and that's very important if you're growing perennial crops, for example. And so the right source, like I said, local, available, sustainable, right? We're not talking about um, utilizing organics that go to another purpose that's really beneficial already, but in a way where we have excess biomass, these would otherwise maybe go to the landfill, or somehow be disposed of. And we want to use these in a more beneficial way. They can be transformed into biochar. So here in the Northeast, I would say the three most dominant sources of feedstocks for biochar production are woody waste, manure, and biosolids. Say in urban settings, these might not be as common. Manure and biosolids. So biosolids are sewage sludge, and this is something that we have active work going on right now in terms of the implications for soil health and crop productivity. So we do not have recommendations for utilizing biosolids, and this would not be something to use on food crops anyways. So I'm just making you aware that this is a potential feedstock. It's a way to greatly reduce um, uh, materials coming from a wastewater treatment plant, but you can kind of ignore biosolids in the context of urban farms. I was just putting that out there. Manure, where I am in New York, this is a huge uh, potential feedstock, and we have work looking at producing dairy manure into biochar, as I previously mentioned. But I would say the most relevant one in the largest scale and most widely available feedstock in the Northeast and particularly in New York State is from woody waste material. This is one you can find readily available. Biochar is sold at garden centers. Woody biochars are mixed in into medias already. And so this is probably the most common one. It's clean feedstocks usually, and a great source for biochar. So the right place, where do I apply biochar? And I've skipped kind of what you see behind the text I have here as the example, just because it's not as relevant. And I just wanted to provide the summary information for you all. But when we think about biochar applications, we're really trying to target degraded soils or low quality, poor performing soils, sandy soils that are low in soil organic matter, or have low cation exchange capacity, what you see here, or soils that might be more acidic, so have low pH, and we're looking to help neutralize that pH. And so when we have a lower soil, these degraded soils, sandier soils, the likely of having a positive yield response and an overall, crop improvement from a biochar application increases. Our higher quality soils and ones that already have high organic matter, and adequate, pH for crop production and other properties like good cation exchange capacity, the likelihood that biochar will have a positive response on yield is lower. That's not to say it's not there at all, but often it has been negligible, and there might not be a return on investment through a biochar application. And so when we are thinking about biochar applications, no matter what farm, you have we're targeting those more degraded or lower quality soils. Within construction soils, which is often very common on urban farms, whether I have compost or there's some type of potentially soil, or a small component of it is soil. These biochar would work well as part of a soil blend, and I'll talk about that in the next slide when we think about the right rate. So more is not always better when it comes to biochar. We want to get that carbon back there, which will enhance microbial activity, enhance the water and nutrient retention, and a host of other benefits. But we're not looking to grow in 100% biochar, for example. If we take this garden bed, this raised bed, and this is actually up in Harlem. So as I mentioned before, right, the application rates differ. But a really good starting point if you're looking to get into utilizing biochar or trying it out in a raised bed is thinking about, if I had all this volume here, about 10, could I replace 10% of this with biochar? Um, Here are some other calculations depending upon the size of bed you're working with or plots. Gives you some sense of a good starting point. That's not the only value you can use, but it's a kind of a rule of thumb, about 10% of biochar on a volume basis there. If you have some trees or container plantings, again, 5 to 10, 20% by volume is a good uh, range to shoot for. This is just, I kept this here. If you do have larger scale fields, these are some larger rates to get you started. And I would say this is often the number one question I get from farmers is how much do I apply? And so I can't give you a specific rate to apply for your fields, for your situation. But I do like to provide ranges for farmers as just a general starting point, that we know these are safe application rates, and you could apply potentially more than once. So when it comes to applying, one of the most important things, and I might mention this before when talking about raw biochar versus blended biochar, is this idea of inoculating or charging the material. And you might have heard this before, but this is the idea that raw biochars themselves, when they're freshly produced, they're a very inert material. They're really just that carbon framework that, for a woody material, that 90% carbon, just that backbone. There's some exceptions, right? Like those feedstocks like manure have a nutrient value to them. They there is some yeah, there is some nutrient value to those. But when we're talking about like a woody based feedstock, they're very inert. And so you've heard me say biochar, it's a soil amendment, it's not a fertilizer. So we still need to be meeting the nutrient needs of the crop we're growing. And so biochar is that backbone. Um, but we need to think about adding those microbes in the nutrients to initiate surface reactions within the biochar. So that's where the mixing or this inoculating or charging the biochar itself before actually applying it to the soil is really critical. So we don't get any type of nutrient immobilization or possible yield drag or yield hit. And so um, this would be where, you produce a biochar and you blend it with compost or manure or some type of microbial solution like a microbial tea, and you let it sit for a few weeks before then you add it to the soil. And this really helps the microbes kind of populate the biochar and reduce any potential impacts to future yield. Because as I said before, that biochar is a sponge, and if you apply just a dry sponge to the soil, it's going to soak up the water, it's going to soak up the nutrients. So it's important to really mix the biochar before application if you can. As I said, I mean, there's really no consensus on the exact amount of time. I've talked with many colleagues about this many times, but a few weeks is likely sufficient. These are just a few examples of potentially how biochar could be charged, like I said, mixed with compost. If you use a compost tea or another type of microbial solution, you can soak the biochar in that. If you grow cover crops, for example, if you're planting cover crops after you harvest in the fall, within your beds, for example, if you're planting like oats and peas, or a rye or something, you could add biochar at that time, mix it into the soil, kind of let it field inoculate, we say. So there's different ways you can inoculate the biochar. And then the last one is the right time. So you can make multiple applications of biochar or you can make a single application. This really depends upon your cropping system, right? So if you're working with an annual crop, you have more opportunities to make these repeated applications or small scale additions of biochar over time. And this might better align with current management practices. Single applications are, I would say, advised if you're working with perennial cropping systems like trees, where you can get that biochar deeper into the future rooting zone of a crop versus later on just top dressing on the soil surface where it wouldn't have as much of an impact. You really want to get it down into the root zone of the cropping system. And if you're a rooftop farm, you're not going to be replacing the soil on an annual basis. So you might want to blend biochar into the mix before you're establishing those fields. And I know some rooftop farms do. Biochar is part of a mix because it's incredibly lightweight material, so it can help meet some of those engineering specs around gardening on rooftops in urban environments. And so there are many ways to apply biochar at all different scales. As I mentioned, this is just once again for your knowledge, kind of a lot of suitable equipment that can be used at a larger scale to apply biochar on farms. So one of my main areas of interest in working with farmers is these practical applications. How do we utilize existing equipment that farmers already have on their farms to actually get biochar out on the landscape? And so one of the great ways is a lime spreader. A lot of farmers have that, not smaller scale urban farms, but this is just some standard equipment that large farms or medium-sized farms have. I would say often in the urban settings and smaller scale applications, it's just going to be hand applications. Buckets, shovels, rakes. These are really going to be the tools and tools that you already have at your disposal to apply biochar. Mixing biochar with compost and then using 5-gallon buckets to spread it on plots. Using those shovels to get it out there, raking it in, or if this could have been done before establishing these nursery crops, that would have been great. But these are really, it's easy to get out there on the landscape, so you can work within with the materials that you have on hand. A few other points when it comes to applying biochar is that the biochar it's very light, as I mentioned. It's a very light material, and so moistening it before application is a really great idea. So adding water if it's too dry, or blending it with the compost, or another amendment you're applying. This will minimize dust and it will reduce the risk of loss, whether it be through wind or water. Get that biochar incorporated into your soil, whether it's in garden beds or a full garden bed, or you're just top dressing. Get it incorporated, and that will help make sure it stays there. Wear appropriate personal protective equipment if needed. So thinking about maybe an N95 mask to potentially reduce any particle inhalation. Safety goggles just so it doesn't get in your eye if it does blow, and maybe some just gloves. It's more you just don't want to be breathing in fine particles. And I already mentioned these pelletized and prilled biochars. Not as relevant right now. I kind of wanted to just mention these top 4 points for you all. And so, a few examples of applications that are happening on urban farms here in New York. This was a project started by a previous CCE educator, Michael Kincaid, in partnership with us at New York Soil Health, in working with the GROWS team, this Gaining Relevant and Outstanding Work Skills group up in the Rochester area. And so they were teaching, or Michael was really interested in biochar and actually teaching youths how to produce it, use it, and the overall benefits of biochar use on urban farms and gardens. And so this top picture is actually them mixing biochar, I think, with this was a compost at some point, but they were blending it to inoculate it before applying to raised beds. This is a youth applying the biochar or laying it out before incorporating it into a raised bed. They were growing radishes, and they had a lot of success with utilizing biochar along with worm castings, actually was the blend they were using. So they found the radishes grew better than the beds that did not have radishes. I think you can see a bit here on either side. This was the bed that actually did have biochar and worm castings in it, and they incorporated it at a mix of 25% biochar by volume, so on the higher end of the biochar applications. But this, I think, has been a very successful project, or it was for a couple seasons. I'm not sure where it is right now, but I did want to highlight this project that's happening in Rochester on Urban Farm. Another work, obviously, there probably, I mean, Yolanda and Karen know this. There's a lot of biochar activity happening in New York City right now, which is really awesome. Um, I'm wrapping up, Yolanda.
Yeah, no problem.
And so just wanted to highlight the work that's happening in New York City, Biochar in the Bronx, and this is really being led by Kwesi, Karen, I think Bill came down for a training, Cheryl there at New Roots, and many others have been involved with this. They've been doing some hands-on sessions in terms of producing biochar, inoculating it, and applying it within the raised bed system. So there's a lot happening in New York City with biochar right now. There have already been workshops, and there are a number, I believe, coming up. Um, and this has been a really great effort. Another colleague, Dr. Rebecca Nelson here at Cornell, has also been collaborating with Kwesi and others and Karen in New York City um, with applying biochar. And this is Bissell Gardens. I'm not sure exactly where in the city that is. I apologize, but this was applying biochar recently.
The
Rebecca's been doing
Bronx.
a lot. What'd you say?
The Bronx.
The Bronx. They're in the Bronx
Yeah.
as well. So a lot happening in the Bronx with biochar, a lot of interest there. And so Rebecca's done a lot of work with actually utilizing hay bales to plant vegetables. So a really kind of low input type of food production. So looking at applying biochar to those. She's also looking at pasteurized urine for that as a source of nutrients. So these are just some really innovative ways that it's being used. And there's a lot of interest there. And I think been fairly successful so far. So just a really cool way to be thinking about utilizing biochar and getting it out there for crop production in urban environments. So this is just a summary slide for you all. Just thinking about biochar as another amendment out there, but not a silver bullet, but one that can be integrated into existing practices that you are already utilizing on your farm, whether it be compost or cover crops. But it's another tool out there that can provide a lot of benefits. And so with that, I wanted to leave a few minutes for questions if there's still time. There's my contact information if you would like to follow up. But I'd be happy to answer any questions. Thanks again, Yolanda.
Thank you. Yeah, so if anybody has any questions, feel free to unmute yourself or put it in the chat box.
Hi, this is Rona. I have a question. My current context is like a community garden, and
Mhm.
I know that members of our garden are interested in biochar, both producing it and using it in the garden. And also I'm interested in it because I've been working with the Land Steward project around adaptation and mitigation strategies. And so just wanted to see if there was like a more like I guess formal way to learn about it. Like I don't know if you mentioned that there were certifications or some way to like um I guess get more you have a more structured way of kind of learning about the process and its application.
Yeah, so there's Quasi and Karen, I'm not sure if you're a part of it anymore there, but they're running this biochar in the Bronx program, which they're doing hands-on training and burns in the city to actually
Yeah.
produce biochar utilizing those small kilns, which I mentioned. I think I know Quasi has a Kontiki kiln somewhere there, and that might be at New Roots. But yes, there are workshops coming up this spring, so that might be something you'd be interested in getting involved in. Um, so that's something local within New York City. If you are in New York City, Rona, there are larger growing with biochar trainings that the American Biochar Institute is leading. These are, I would say, larger scale farm applications, but I think the biochar in the Bronx workshops that Quasi is leading are probably most relevant for you.
Yeah, I'm
Wonderful.
putting
I
that
think
link
I
in.
might actually see him this Saturday because I think he might just be talking about soil and soil health with the Seed to Supper program that we're piloting downstate in Brooklyn.
Great. I would definitely talk with him because I know he would be excited to have as many people who would like to come to the workshops as possible.
Mm-hmm.
Yeah, and that would be great in terms of learning how to produce biochar at a small scale in some of those artisanal kilns that I mentioned.
Yeah, thank
Wonderful.
you so
Thank you
much.
so, so much.
Yep.
We had another question in the chat box. If you take a look.
Have you tested have you tested soil before that one?
Yeah.
Have you tested soil before and after using biochar? My thinking is we have an orchard area in our school garden, and we are always concerned about the health of that soil, working on collecting samples for testing, thus wondering, as per results, how to use it and how long it can take to improve the soil. So that's a great question. So I definitely recommend testing soil before and after, or I would say definitely before application. So you know what you're working with, and this is true before you apply any amendment, not just biochar. So definitely collecting baseline soil samples are essential. And then, yeah, for plenty of projects and farm applications, we've tested soil after, whether it be 1 year or 5 years after biochar application, to see what were the changes, right? How do we know what actually happened through a biochar application? And so often what we see, decreases in soil bulk density, improvements in soil pH, increases in soil carbon or soil organic matter in fields. That's a big one, right? Because we're adding a lot of carbon there. And so if you need guidance on how to properly collect a soil sample in a garden soil, feel free to reach out to me or reach out to Yolanda. We have resources available to help with, how to collect a soil sample and then how to apply an amendment. So thinking about an orchard area. So as I mentioned, that's a perennial crop. So ideally, if it's a new orchard, you would want to apply the biochar into the future planting hole or rooting zone of the tree. If you've already established the orchard, top dressing it is an okay option and better than nothing. Um, but yeah, if you follow up, we can talk about your context specifically, and how long can it take? So it it can be a long time. So I think I could give a whole talk on soil health, but soil health really can take a long time to change. A lot of the indicators we think about for measuring soil health, these can take years and years. So it's a long-term view to soil health improvements, but changes in soil organic matter, changes in pH through biochar applications, these are parameters that can change very quickly within an annual period. For example, I've seen that happen. So there are short-term, but then also longer-term improvements when it comes to soil health. So hopefully that helps a little bit. Um, Feel free to follow up with me if you'd like to talk about your situation specifically. I'd be happy to do that.
Thank you.
Yep.
Any more questions? I did put in the chat a link to register for those upcoming biochar workshops. And then I'm also going to put a link to an upcoming Urban Agroforestry Summit. The date for that is July 14th. It'd be great to see some of you there. If we don't have any more questions, then we can wrap up. All right. Thank you, everybody.
Thanks so much,
Thanks,
Alana. Thanks,
Debbie.
everyone.
Thank you.
Bye.
Bye.